Chemistry. What is it? What does it do for us? How can we study? Throughout the world, in such industrial laboratories as this, new products are discovered. New chemistry is concerned with the structure of matter and how that structure can be changed. In many ways, our daily life is affected by the operations of such laboratories. From lumps of coal, chemistry produces nylon for hosiery and hundreds of purposes. From raw petroleum, synthetic rubber, and a host of other products. Mold plant, a powerful drug, penicillin. How can we study this science of chemistry? The answer to this question lies first in the way a chemist looks at the world about him. Of what is this world composed? What is the composition, the materials in the crust of the earth, of the waters of the earth, and the atmosphere around us? In these, the chemist sees, first of all, the elements of which they are composed. The pure states of matter are called elements. About 100 elements combine to form the millions of different substances in our world. You are probably already familiar with some elements: carbon, nitrogen, oxygen, neon, magnesium, aluminum. We divide the elements into two types according to the way they combine chemically. About 3/4 of the elements are called metals. Chemistry teaches us the relation between the properties of aluminum, commonly used for structural purposes; iron, for nails and many things; copper, for scouring pads and wire; silver, for spoons and tableware; and gold, as in jewelry. On the other hand, about 1/4 of the elements are classed as non-metals, and in general have different chemical characteristics from the metals. Non-metals include carbon, as in coal; phosphorus, in the tips of matches; sulfur, seen here in its natural state; and iodine, used in disinfectants. So there you have the two types of elements. Now, most matter is made up of combinations of elements in the form of compounds or mixtures. For example, of the metals, mercury is found as an element in nature. Aluminum is usually found as a natural compound, and gold and silver often together as a natural mixture. To obtain aluminum as a refined element, it is necessary to separate it chemically from its naturally occurring compound. From this refined aluminum, various compounds, such as aluminum chloride, are made. Or the refined element may be mixed with other elements, such as copper, to make an alloy. To understand more about mixtures and compounds, let's take the element iron and mix it with the element sulfur. When the two elements are thoroughly mixed, what do we have in the beaker? Let's divide our sample into separate portions. We'll have 2 portions in test tubes and 1 left in the beaker. In the beaker, with a magnet, we can physically separate the iron from the sulfur because the iron retains its physical characteristic of magnetic attraction. Or we can use the solubility of sulfur in carbon disulfide and so physically separate the sulfur and iron in one of the tubes in another way. The iron filings do not dissolve and are caught by the filter paper. while the dissolved sulfur flows into this evaporating dish. When the solvent has evaporated, we find tiny crystals of sulfur in the dish. So we know we have been working with a mixture. We have been able to separate the mixture physically into sulfur and iron. Now, suppose we heat the remaining sample of the iron and sulfur mixture. After a moment of heating, the mixture begins to glow. Even after the tube is removed from the fire, the glow continues. This release of energy is one sign that a chemical reaction is taking place. And when the test tube is cooled, we can remove a black, powdery solid. What is this substance? Will the magnet affect it? No. Will it dissolve in our solvent of carbon disulfide? No. We have neither iron nor sulfur. We have a new substance called iron sulfide, not a mixture, but a compound. Compounds have properties different from those of the elements they contain. We have to use chemical means to separate a compound into its elements. Let's take the compound mercuric oxide, which can be separated into its original elements very readily by chemical means. When heated strongly, the mercuric oxide will decompose, and after a moment, tiny drops of mercury gather on the walls of the test tube. And what other element is being produced in this chemical reaction? As this simple test shows, it is oxygen, the element which causes fuels to burn and is necessary to support all animal life. And so we have seen the formation of one compound and the decomposition or breaking down of another compound. Of the many types of compounds, 3 are especially important: the bases, the acids, and the salts. Let's see how these types of compounds interact. First, let's understand the acids. For example, sulfuric acid, a compound of sulfur. When acids react with certain metals, in this case zinc, we see the release of the element common in all acids, hydrogen. Acids are made up of hydrogen combined with a nonmetal, or of hydrogen combined with a group of elements which together have the chemical properties of a nonmetal. Then there are the bases, for example, barium hydroxide. Bases often are compounds of metals containing hydrogen and oxygen, hence the name hydroxide. Bases and acids react with one another, neutralizing each other to form a third class of compounds, the salts. Here, barium sulfate. We have learned some of the important ideas in chemistry, and we have learned that chemistry is the study of elements, compounds, and mixtures. We have seen examples of 2 types of elements, metals and nonmetals. We know that metals form basic compounds, and nonmetals form acid compounds. And when bases and acids neutralize each other, a salt is formed. With this background, and with detailed knowledge of particular elements and compounds, chemistry seeks answers to such questions as these. What materials are light, yet strong enough to be used in airplanes? What various compounds and mixtures can be made from this sulfur? What chemical and physical properties of this plastic make it so useful? What chemicals can help cure diseases in mice and in human beings? Yes, to these people, chemistry is important. It is their livelihood. From research to production, chemistry gives us benefits every day of our lives.